Our 10th lesson is on inverse functions at the Tier 3 level. Find the inverse function of f of x equals 3 over 4x minus 3, or we could say 3/4 times x minus 3. Then graph both f of x and f inverse of x. What we're going to do is we're going to add 3 to both sides. F of x plus 3 equals 3/4 x. We could do one of two things. We could divide both sides by 3/4, but that's kind of complicated. Or we could multiply everything by 4 to cancel out that dividing by 4, which I think is a little easier. So 4 times f of x plus 12 equals 3x. And now I can divide both sides by 3. Makes it a little easier to see. So divide everything by 3. So 4/3 times f of x plus 12 divided by 3, which is 4, equals x. Now I'm going to just change my notation a little bit. F inverse of x, right, equals 4/3 x plus 4. So now I'm going to graph both. My original function started at -3 and had a slope of 3/4. So 1, 2, 3, 1, 2, 3, 4. My new function starts at 4 and goes up 4, right 3, which I can't do because that goes too high, so I'm going to go the opposite direction. Down 4, left 3. So what do we notice about the graphs? Well, the slopes are opposite, 3/4 and 4/3. That's kind of interesting, and we see that they're coming together down here. It's hard to notice, but inverses are reflected over the line y equals x. So you can see that this line is perfectly symmetric to this blue line. So when you graph some more of these, hopefully you'll see that a little bit better. You can see it's symmetric because this is equidistant to this. I bet you thought geometry was going to go away. Well, it won't. There's some geometry for you. And look, we have a triangle. We could prove that this is symmetric with these two triangles, right? What could we use? We could use this side is the same. These two lengths are the same. And we could use some coordinate geometry to show that these lengths are the same.